Hi everyone, welcome to this new video for you to practice your maths at home. We're going to carry on with our units. We're going to start unit 40, all about probability, and we're going to look at doing a number of different things. I'm going to try and split these lessons up so that we do the experimental probability first, and then we're going to look at the more theoretical probability afterwards. This is aimed at everyone doing higher GCSE, I mean specifically for the year 10s, but anyone else that's watching this video, it'll be useful for you for revision, and your unit numbers might be different if you're at a different school to ours, but fundamentally this is all about experimental probability. So I say we're going to start a new topic. Specifically in our probability topic, we're going to be looking at combining events. We're going to look at mutually exclusive and independent, and these are all theoretical stuff. We're going to do conditional probability. We're going to do some Venn diagram and set notation. So those of you that got worried and concerned about the question that was on the mock that we've just done, we'll be going through that. But specifically today, we're going to be looking at this one, all about experimental probability. So the sorts of things that we're going to do are literally all about the chances of things happening based on an experiment happening. So here we've got an experiment, a drawing pins repeatedly dropped in an experiment to see which way up it will land, and here are the results. So we've dropped it 20 times and it's landed point up 15 times and point down 5 times. What do you think the probability that it will land point up is? Okay, and the correct answer is 3/4. That's because it is 15 out of 20 times. And 15 out of 20 as a fraction is 3/4. Notice that we're going to be writing these as we do all probabilities as a fraction or a decimal or a percent using our number line between 0 and 1. Next question then. So it's exactly the same idea. We've dropped a drawing pin, dropped it more times this time, and we want to know that it will land point down. So 35 out of the total, 35 out of 100, 35 out of 50 is our answer. Now, of course, that does cancel down. So if it can cancel, you might see certainly multiple choice questions being cancelled down in that way. So you might need to do a little bit of fraction work, but otherwise 35 out of 50 is a perfectly sensible answer and a reasonable thing to do at probability. You don't always need to cancel down your fractions when we're doing probability. Next quick question to kind of test understanding. It says it's been thrown 60 times. So if always look in the question first before you start adding up. So 60 times, what's the probability it will land heads up? We've got 27. So 27 out of 60. Molly's asking a number of people about their age and recording it in a table. So instead of having, like on the last one, some fixed things, we've now got groups. So between 0 and 20, 21 and 40, and so on. What's the experimental probability that the next person Molly asked is aged 21 to 40? We need to simplify our answer. So 21 to 40, we've got 3 out of 10, and that's because we've been asked to simplify the answer at this point. And in this final example, it says that Molly asked a number of people about their age and recorded it in a table. So it's the same table as before, but this time it's people being over 40. So we need to look at combining a couple of categories together and think about how many it's out of in total. So this time we've got 41 out of 80 because it's the combination of both of these classes here out of the total. Last example, we've got ice cream shop recorded the number of customers purchasing ice creams for the 4 flavors below. Experimental probability that the next customer will be vanilla or chocolate. So again, or we're having to add the two things together, vanilla or chocolate. So 30 out of, again, 50, because it's the total number of people here. Okay, so we've seen quite a few of the examples to do with relative frequency and experimental probability. In terms of what we're going to try and look at doing, we need to be able to recall how we're going to do this. That's what the most basic of the outcomes. Then accurately applying this skill to be able to calculate probabilities, and being able to problem solve using this experimental probability to forecast outcomes and understand the limitations of the data in front of us. If you're making notes in your book, this would be the first kind of place that I'd pause the video and start making notes. So relative frequency, we've got, again, in most events, it's difficult to accurately predict the probability of an event happening. When there's no theory behind the probability of an event happening, we can use relative frequency to calculate the probabilities. So if that's something that's not like a dice being thrown or a coin being flipped, then we might need to do an actual experiment to work out what our chances of things happening are. And because it's calculated after performing an experiment, it's often called experimental probability. But these two things, relative frequency and experimental probability, are fundamentally the same thing. Again, if you want to write down an actual example, so this case we've got the probability of picking a vegetarian at random from a group of people can be found by using relative frequency. The easiest way to calculate this is by doing an actual experiment. In a survey of 200 students, 28 said they were vegetarian. So we're going to use this 28 out of 200, which is 14 over 100 or 0.14. That is what we're going to use as our probability that somebody chosen at random is going to be a vegetarian. 14% chance. Now, this is out of 200. We need to be careful that our sample size here is as big as possible to make it a usable, fair thing. If I only asked one person and that one person said that they were vegetarian, that 100% would not be a suitable sample size. So one of the things we're looking for is this value to be as big as possible to make this more accurate. Okay, question for you to try by yourself then. Again, at some point during this video, you're gonna have to pause it. You're gonna have to draw out this table. Fred records the colour of 100 cars that passes his house. He's obviously in self-isolation, really bored. So he's recording the number of cars and the colour. He's done a little table. First thing you'd be asked to do is calculate the relative frequency or the experimental probability of each colour. Then we're going to work out the probability that the next car passes his house will be red, blue, and not black, and that is using our relative frequency, our experimental probability that we've calculated in question 1. And then we're going to predict forwards. So question 3, on average 3,500 cars pass Fred's house. Based on his results, how many of these would we expect to be silver? So if you want to pause the video, draw out the table, do as much as you can, and then I will explain the answers shortly. Okay, so your relative frequency, notice that this was out of 100. So we've got 10 out of 100, which is 0.1, 15 out of 100, 0.15, and remember every time I say out of, we're doing a divide, 38 out of 100, and so on and so on. What's the probability that the next car to pass his house will be red? Well, red, we can see we're using our relative frequency, so 0.1, blue, 0.15, and not black. So we can't have this one. You might notice that all these add up to 1. So 1 minus 0.32 is going to be 0.68, so not black. And then we're going to use this information to project forwards. So on average, 3,500 pass the house. Based on his results, how many of these 3,500 will we expect to be silver? Well, the chance of it being silver, the probability of being silver is 0.38. So we're going to do 0.38 multiplied by 3,500, and that gives us the number of cars we expect to be silver. Here's an activity for you to try at home. You're going to need to go and get a dice. You're going to have to draw out a table, and I would like you to find the dice, roll it 50 times, record your results in a tally table below. Once you've got all your tallies together, you can turn your tallies into a frequency. So that's just the number that's in your tally. Then you're going to work out your relative frequency. So the frequency out of 50 will be your relative frequency here. So the number of times it landed on a 1 out of 50 will be this. Then I want you to think how that relates to this. So does your observed relative frequency look like the expected value? Bear in mind that the chance of getting each of these is 1 out of 6. So we would expect 1 divided by 6, 0.17. We've rounded that up to 2 decimal places, but fundamentally 0.17. How does it compare? And what could you do to get your observed values closer to the expected values? Now, once you've done it, you might want to do it 50 times. If you're really bored and you want to do it more and more and more and more times, hopefully you should get closer and closer and closer to these values here. There's a worksheet for you to practice next. So on class charts, there's a worksheet for you to try. Alternatively, if you're watching this video and you've not got access to the worksheet, I've used this from Pixie Maths. So if you go onto the Pixie Maths website, you'll be able to download her worksheet from there, which is absolutely fine. You can do that. Alternatively, once you have if you've got your worksheet, you need to be having a go at it now. The answers will appear here shortly for you to see, so you can mark it. And here are your answers. Make sure you're marking everything. Use your green pen as normal to correct any mistakes that you've made. You might need to go back over the video and check any bits again, just to make sure you've got some detailed understanding. And then the final thing I'm going to ask you to do. Okay, and so the last thing that I'm going to ask you to do then is to practice this skill further. So you've probably already done your worksheet. The next thing to do is to find some exam questions. Students at Tupton Hall, I will have set you some work on Dr. Frost Maths, so log into that. Make sure that you are answering the worksheet that I've set you online. If you can't get access to that for whatever reason, number one, if you're from Tupton, you can get in touch with me via email and I will help you get set up. If you are watching this from a different school or you want an alternative resource, corbettmaths.com. You need to make sure you're looking for the keywords that are relative frequency or experimental probability, or any other website that you can find online. The worksheet that I've used from here is from Pixie Maths. Like I say, there are lots and lots and lots of online resources for you to be able to access and practice this skill. Hopefully you found this video useful, and look out for the next one in this series. We're going to do all of Unit 40 via video, so make sure that you keep subscribing, make sure that you like the video, and then finally, any questions you can contact me by email. See you later. Bye. Stay safe.